For effective communication, humans need to agree on how we talk. In person, on the phone, using messenger pigeons, whatever. How far apart we are and how quickly we need to get the information transported between us dictates which communication method we choose. When electronic systems talk, they must agree on a communication protocol. Most of us are familiar with protocols like Bluetooth and Wi-Fi, but we may soon all be living in smart cities enabled by the Wi-SUN protocol for mesh network communication over long distances. Here to talk to us about Wi-SUN is Soumya Shyaman-Sundar, product manager at Silicon Labs. Soumya, welcome to Tech Chats. Hello everyone, I'm Kate Smith, the editor-in-chief of All About Circuits, and in this Tech Chat we're going to be talking about Wi-SUN, which is short for Wireless Smart Utility Network, and this is a wireless communication standard that's intended to help smart cities, be smarter. So here to help us make sense of the why and the what behind the standard, as well as understanding the implementations and what that looks like for hardware engineers, is Soumya Shyaman-Sundar, product manager at Silicon Labs. Soumya, welcome to Tech Chats.
Hi, Kate. Thanks for having me here.
All right, so let's start with the basics, shall we? What is Wi-SUN?
Yeah, that's a great question. And we get this question often. So I kind of thought that it would be good to talk about the background before really driving into the emergence of Wi-SUN. So historically, smart city verticals were very fragmented with a number of different proprietary technologies in play. These technologies often lacked interoperability, didn't have an ecosystem, security was outdated, and also had very limited options to upgrade. And customers were also locked into one hardware vendor. And of course, in-house maintenance costs increased with time. Customers are now slowly moving away from proprietary solutions to standards-based solutions for benefits like flexibility, ease of use, and also to avoid vendor lock-in. So standards-based technology, as you see down here, provides end customers options to choose from different hardware, software from a variety of different vendors. And the main thing is it avoids vendor lock-in. Smart city applications, as we know, are often built independently, one piece at a time, and are used for a very long time. And often, over time, some of these pieces may need to be integrated directly into the main solution. Mm-hmm. That's why open standards are strongly preferred, and certification programs are needed to ensure multi-vendor interoperability and options for multiple vendors to play or offer their solutions for these large network applications. The other thing is it allows customers to focus their internal developer resources on the application layer, where they can add more value and bring differentiation rather than building the same networking stack that is a standard. Lastly, it also allows OEMs to deploy and go to market quickly with the latest and greatest, including an opportunity to integrate advanced security features and things like that, which weren't possible if they had their own technology or a proprietary technology. So this is sort of the background behind why Wi-SUN came into being. And on the next slide, we can kind of talk about what it is and what benefits it brings to the table.
Awesome. So yeah, let me just ask a couple quick questions here about, obviously, I think a lot of people are going to be, if they haven't heard of Wi-SUN, maybe you could help them understand what Wi-SUN is trying to replace, because you're talking about this concept of there were these proprietary standards, and obviously, basically what it shakes down to is that the devices had a really hard time talking to each other because they might be speaking different languages owned by different companies. Is that about the size of it?
Exactly, Kate. You distilled it down really well. So that's exactly it. So all these different proprietary technologies couldn't talk to each other because they weren't interoperable at all. And this kind of forced the customer to use a solution from one specific vendor, and they had to stick with that for years to come. And that sort of brought in the disadvantages of either limited security or increased maintenance costs and vendor lock-in and things like that. So Wi-SUN is here to solve that problem.
Right. And we're going to get into some of those applications that we're talking about. We're going to dig a little bit more into what smart city really means in this context and what that looks like on the hardware level, all kinds of good stuff. But for the moment, it's really important kind of what you've mentioned. You've mentioned security a couple times here, right? Because as we're developing smart cities, we don't really know exactly, I mean, at least I don't really know, maybe you have a better idea, Soumya, of exactly what we're going to need for these massive scale systems. So you've mentioned security. There are all kinds of questions about what advancements we're going to have with power and connectivity and all kinds of things that, I mean, how far do you see down the road? How do you envision a smart city, you, Soumya?
Yeah, that's a great question, Kate. So Wyson so even before Wyson, there was no one comprehensive standard that kind of met all the requirements for a large network smart city application and also future proof the entire infrastructure or entire network, so to say. And that's where sort of Wyson comes in, or that's why Wyson came into being. It is one single standard which meets all the requirements for large networks spanning thousands of nodes. It has drawn in all the strengths and benefits from these older proprietary technologies and has become a new standard of its own, albeit with many advantages and very few, I wouldn't say disadvantages, but limitations when you look at the overall picture. So there are other semi-standard technologies like LoRa, but they are limited when you have to scale beyond a couple hundred or a few hundred nodes, so to say. So we will talk about a use case, a real world use case later on in the deck. And I can tell you how a city today is deploying Wyson with their existing street lighting nodes and how they plan to use the same network over the next 30 to 40 years to deploy some of these emerging sensor node applications like parking or manhole detection and things like that on the same network. They don't have to rebuild the entire infrastructure for a number of years because Wyson is that future-proof or offers a future-proof solution for all emerging as well as existing applications.
Awesome. That's perfect. I think everyone listening is probably going to have some questions about that. As technology moves very quickly and advances very quickly, how do you even approach designing a standard? And I know that we're going to talk a little bit more about that as we move forward as well. So as you were sort of mentioning, if we want to dig a little bit more into the specifics of Wyson, and maybe you would be willing to help people understand what it offers compared to, for example, like you mentioned, LoRa.
So I mentioned that Wyson is a comprehensive standard that meets all the requirements for large network smart city applications. Wyson stands for Wireless Smart Ubiquitous Networks, and it is an open standard space technology governed by field area networks or FAN specifications, as we call it. FAN addresses specifications for the PHY or the hardware itself, the networking protocol stack, as well as the combined networking product. And we'll go a little bit deeper into the architecture later, but broadly, Wyson PHYs are based on the 15.4G standard. It's an IEEE standard, open standard, mature standard. The protocol stack is based on the IPv6 mesh with the 6LoWPAN adaptation there. And again, the same benefits of open standards, mature standards that have been in existence for a long time now. And this is in contrast with what LoRa brings to the table, especially on the protocol stack level, because LoRa is not IPv6 compliant today. Yeah, the other thing is Wyson is frequency agnostic and can operate both in the 2.4 gigahertz spectrum as well as the global sub-gigahertz bands. Although we've seen sub-gigahertz being more dominant, mainly due to its advantages of providing longer ranges. LoRa today operates mainly in the sub-gigahertz band. The other comparison or benefits, so to say, with Wyson is it is one of the best known technologies to support thousands of nodes, if not more, mainly because it's a mesh technology and it can scale very easily and does not depend on one single gateway to service all its end nodes, which is sort of the architecture that LoRa follows today. Wyson is also extremely versatile, mainly because it offers a solution for both high throughput, line-powered applications as well as low data rate, long-range, battery-powered sensor nodes. And this is a pretty big contrast to LoRa because LoRa today is suited mainly for long-range battery-operated applications only. Once the data rate goes beyond a couple kilobits, LoRa starts to suffer quite a bit, whereas on the Wi-Fi side, you can go up to 2.4 megabits per second with some of the PHY options that it offers as part of the standard. And we can talk about those or PHY options later here in the slide. Yeah, so those are a couple main differences, I would say. And yeah, LoRa is very well suited for specific smart city applications that need battery operation and low data rate. And Wi-Fi is more suited for dense urban areas, which are predominantly need high throughput or high data rate line powered nodes and things like that. So that's a couple of the main differences between the two technologies, I would say, on a very high level.
Oh, that's perfect. And we kind of ran kind of past that concept. I'm sure that a lot of our audience is going to be very familiar with the concept of a mesh network, and you did a great job of sort of explaining some of its base characteristics. Can you help us contextualize it a little bit more about, in terms of what are mesh networks extremely good at, and how can those, if you're designing for a mesh network, how does that change the way that you're designing the hardware?
Yeah, that's a good question. So we mentioned field area network applications before, but what does that really mean? So field area networks are characterized by large geographical areas, typically large number of connected devices, and also networks that need remote monitoring supported in an economically feasible framework. Historically, utility networks had all these attributes, but now with the emergence of smart cities, some of the same characteristics can be applied to applications like street lighting, environmental sensor nodes, parking, and so on and so forth, where a technology like Wi-Fi can provide all the benefits of long-range and secure self-healing mesh to build out some of these new and emerging smart cities of the world. Wi-Fi is very well suited for dense urban areas, mainly because of its mesh architecture, but it can be used for all the applications that are seen here on the slide.
Real quick, when you're talking about, it's one of the questions that you kind of have to ask, right, is when you say large scale, like how big are we talking here? Are we talking about, an area of, square miles, or what scale are we looking at?
That's a great question, Kate, and a lot of our customers ask that, or often wonder about that, I should say. It is square miles is what I'm referring to, mainly because Wi-Fi is a mesh, and a mesh network doesn't have any theoretical limits, because as then when you add more nodes to the mesh network, the network grows, and thereby you extend its range, and you extend and build out the network as well. One good example here, and it's not a very large scale, but reasonably large scale, I should say, is the City of London. So the City of London has deployed Wi-Fi for their street lighting nodes. Today, they have about 15,000 streetlights, which are all operated with Wi-Fi or all operating on Wi-Fi. And they expect to add newer sensor nodes for parking and waste management in the years to come to again build out and expand that network. So yeah, thousands is just where we start, but it can very well go up to millions of nodes all together in one single network.
Wow. And that's actually one of the questions that I had as well, is that concept of, what you're describing on this slide, what we're seeing, it's a lot of different disparate sort of applications, right? And, to put it kind of bluntly, I don't know that I've yet to meet a design engineer at the silicon level who, thinks of themselves as a smart city engineer, right? Because what does smart city even entail? And what you have here is a visual representation of all of the different things that smart city could mean, right? So could you help us explain, from your EE background, how do you think about it in terms of, that street lighting example that you're talking about in London? How does that compare to that, environmental monitoring application? How does that compare to your utility meters and that darn oil and gas platform in the ocean? They might look very different from a distance. How do you see those things all being interconnected?
That's a great question, Kate. So here we see a typical smart city example, and You see, the streetlights are forming the backbone or will form the backbone. Streetlights are typically line-powered applications, or in the sense the silicon in the box on your streetlight is always connected to power or always connected to a power line. And that's why a streetlight is a line-powered application. They are the ones that get deployed first to form a backbone. And once the streetlights are built out, other smart city sensor nodes can be added to the same network as shown here. You see waste management, you see parking, you see weather monitoring, you see even some location detection and things like that. So all of them get added once the street lighting network or once the line powered network is deployed and built out. And this is analogous to the utility networks also. On the utility side, your electric meters are the line powered devices or line powered applications. Electric meters are always connected to some sort of a power line. So they are the ones that are deployed and built out first. And then come your gas and water meters, which are typically battery operated sleepy end nodes or long range sensor nodes, which aren't directly connected to an electricity line always. Mm-hmm. So again, very, very analogous to the utility side. We can see some of the same analogies even in the oil and gas sector, where main communication networks, say around circuit breakers or say around other industrial tools and things like that, are first built out. Anything that is line powered is the main primary network that needs to be deployed and built out first. And then all the sensor nodes or all the battery operated applications, long range battery operated applications, are added to the same network, are all deployed to connect to the same network. Mm-hmm. So it's sort of a very similar template across different applications and across different industries. Build out the line powered or deploy the line powered applications first, and then have your battery operated sensor nodes connect to the line powered nodes afterwards. So that's sort of what is depicted over here as well.
That's perfect. It sort of helps us understand that, even though these look like very, very disparate applications, the implementation is actually very similar in a lot of ways.
That's true.
So just very quickly, for anyone sort of wondering about, like you mentioned, like utility meters and how all these different systems work together. Obviously, utility meters have been around for a very long time. And now there's sort of this concept, and, correct me if I'm wrong here, that sort of concept of AMI, the advanced metering infrastructure. What are the benefits of that? Like, if there's someone in the audience just wondering, like, oh, what was wrong with the meter before? What if we're introducing, as you mentioned, there's security issues. There's a lot of things to consider when you're implementing something like this. What's the benefit?
Absolutely, and you're right. I mean, we were in the mechanical meters generation a few decades ago. Then we went to AMR, which is the next generation with wireless devices added to your electric meters. And now we're in the third generation, which is AMI, or advanced metering infrastructure generation. And the biggest benefit that AMI brings to the table is connecting different nodes or connecting different electric meters wirelessly across neighborhoods. So this is a bigger benefit to the utility. They don't have to send personnel to, say, collect metering data or even fixing or maintaining meters and things like that. There's real-time information sent directly from these electric meters wirelessly to, say, a border router first, which aggregates all the data, and then back to the control station so that the utilities have a clear indication of each and every meter, what its health is, whether it's transmitting or not, whether there are any issues in the data transmission back and forth. And even if they have to send information to your electric meters, everything can be done wirelessly. For instance, we had a pretty hot summer here in Austin, or summers are pretty hot always, I should say. But Austin Energy sent out a notification which came to our Nest that told us that if we participate in the Austin Energy Power Conservation Program, we couldn't turn our thermostat below 78.
Oh.
That's the kind of wireless information, or that's the kind of information utilities and energy and municipal energy corporations want to send directly to their patrons without having to communicate over email or phone and things like that. This was pretty amazing because it gave me the choice to participate or not. And if I did, it told me, hey, until 5 p.m., I wouldn't be able to turn down my thermostat below 78. And that's the kind of benefits that AMI brings to the table. A lot of communication between the utilities as well as users directly and, without any friction and things like that.
Yeah, I'm sure you were. Well, I gotta ask, did you end up participating? Did you keep it at 78? That's a bit warm even for me.
That's true. So I think we tried it one day, and then the next day we were like, maybe not.
Nah.
Yeah.
Pretty toasty. Okay, so yeah, there's a lot that, and obviously, if you're dealing with those large infrastructure systems, the same way that we've been talking about them as having, scalability is a huge issue there, but the benefits also come with that scalability, right? Like you're
Right.
talking about, you can prevent strain on a utility system, you can communicate, as you said, seamlessly.
Yeah.
Yeah, interesting.
So here, what we see is a typical mesh or a small mesh network deployment. It primarily consists of three main components or three main elements, I would say. One is the border router, which is very similar to a gateway, and that is sort of the device that provides backhaul WAN connectivity as well as an aggregator of sorts of all the data for one specific voice and fan network. It also maintains the source routing tables and things like that. And you kind of see here on the left side, one border router can service about anywhere between 2,000 to 4,000 nodes, depending upon the processor inside the border router and the horsepower that the border router has. The next element is a router node, and router nodes are nothing but end nodes, or these are the electric meters or the street lights or circuit breakers inside, say, an industrial factory. So these are the line-powered end nodes. Router nodes are line-powered end nodes, and again, very quickly, they are also called as full function nodes because they can forward data upwards and downwards, and they can talk to the border routers as well as their neighboring mesh nodes, as well as some of the sleepy end nodes that will be expected to connect to them later on. So that is sort of the router nodes. All your line-powered nodes are router nodes. They can route data from one place to other in its most simplistic term.
Well, and as you were sort of mentioning before, there's this whole concept of, like what makes for a good, like why do we want these mesh networks, right? And part of it, as you're describing, is that there's a lot of shared load. Is that a decent way to think of it? That, it's not serially set up so that if one node fails, there's a cascade effect. It's much more share and share like of resources. Is that a good way to think of it, or am I misunderstanding?
No, absolutely, Kate. You said it right. So mesh networks are reliable networks with no single point of failure. So exactly to your point, if one meter or if one router node falls off of the network, that doesn't mean all the nodes that are connected or all its neighbors that are connected to that electric meter will also switch off. It's quite the opposite. Its neighbors will find the next nearest meter or next nearest node and connect to them, and then again continue sending the data back to the border router and then back to the control station. So that's the benefit a mesh networks brings. It's self-healing, reliable, and self-forming also. So as soon as it detects another new electric meter in the vicinity, the existing mesh nodes connect to the new meter and again make it part of the mesh automatically. So yeah, lots of good benefits from a mesh network standpoint.
This is a heck of a thing to achieve. I mean, when you're designing a standard like this, when you're designing, when you're looking at this massive application you're trying to address, I mean, holy cow, like you're basically saying this network needs to be long range, high throughput, low latency, low power. And essentially, that's another portion of the equation is whether or not it can reliably communicate through materials like metal and concrete. I mean, where do you even start?
No, that's true. That's why the Wyzen Alliance was born, to create the FAN specifications or to create profile definitions for these specific needs and for these smart city applications, and also create a full certification program that ensures that all the vendors who want a Wyzen device adhere to the set of rules and adhere to the set of features that need to be part of the overall product itself. And the Wyzen Alliance, again, very quickly, they are a global ecosystem of member companies seeking to accelerate open standards for smart city applications. There are about 11 promoter members today. On the right side, you can see all their logos. Silicon Labs is also one of them. And there are about more than 300 member companies doing exactly what you asked. It's like trying to define some of these profiles and features that are needed to meet all the requirements for large network or for large network smart city type applications. And of course, they also create the certification specifications, because at the end of the day, all the Wyzen devices need to interoperate among themselves. So a robust certification methodology and a program is needed, which is also, again, created and driven by the Wyzen Alliance.
Right. Well, quick question on just sort of this sort of global alliance that you're dealing with. First off, I mean, how do you operate across a global stage where there are individual, I mean, you're talking about different languages, different regulatory bodies that they answer to, surely even different metrics that they're using to measure. That's quite a lot of communication that you have to have, right?
That's true. That's true. That's why the Alliance has members who are specifically looking at different geographical areas. And this kind of comes with the sub-gigahertz technology. Sub-gigahertz bands are different across the globe. So the Wyzen Alliance directly works with the regulatory authorities on defining or adding the region-specific bands or approving region-specific bands as part of the Wyzen profile or specification. The one good thing about Wyzen is it is based on the IEEE 15.4 GE standard. So IEEE already defines a robust PHY layer and a MAC layer, which kind of takes care of all the frequency related aspects and regulatory related aspects in the IEEE working group.
Nice.
So Wyzen really adopts what is done or leverages what is done by the IEEE and has defined profiles and specifications for field area networks for smart cities.
Yeah. So if it ain't broke, why try to fix it, right?
Exactly, right. If it exists already, let's just use it and let's just make it better. Yeah, that's true.
Smart. And just out of curiosity, looking at these logos, obviously you've got kind of a mixture in here. You've got some that are arguably hardware-focused companies. I would personally assume that you guys at Silicon Labs would identify in that way from a high level compared to like Cisco, which may be more associated with the connectivity portion of the equation as an identity, as a brand. And then you've got, ARM, which is, quite famously, instruction set architecture
Right.
for silicon level.
Right.
I mean, what do you see in terms of how do you guys represent your different standpoints and your different specialties? Is there an even mixture, do you think? And is it important that there's an even mixture?
No, that's a good question, and I think it's great that the Alliance has attracted a variety of different OEMs and companies to be part of the promoter or to be part of their board. This kind of promotes different viewpoints, because the viewpoint of us as a silicon vendor is pretty different than the viewpoint of Cisco, which looks more maybe from a border router or gateway standpoint. And again, it's very different from the way Landis+Gyr or Itron looks at utility networks. They are the full system here. So it kind of brings a great mix of opinions and also a great mix of next generation or brings a great way to define some of these next generation features required for smart cities. It's also great that it's so well rounded, because from the silicon side, companies like Silicon Labs or Renesas can bring the next generation innovations on the hardware side itself. And then you go to Cisco and Landis+Gyr and Itron, they might be looking more on the system level and on the protocol stack itself side. And then there's the likes of Toshiba or Trilliant who go even beyond that to see what more apart from just the hardware, software, and the system. ARM has their cloud connectivity network management solutions too. So they bring in that perspective to kind of define a well-rounded profile specification that is part of license today. So it's kind of great that way, that it's a mixture of different companies and different perspectives to grow these ecosystem and also define some of the next generation features.
Well, last questions about the Alliance real quick. We kind of have a running joke sometimes when we're talking about, as we already touched on, there are so many different protocols out there, different standards, that sometimes people will rally behind, and it's sort of like they'll sort of make a bet. And we have this kind of running joke about, is it VHS versus Betamax sort of thing? I know there's the LoRa Alliance, for example. Do you see much crossover? Do you see companies that participate in both alliances, or do people tend to pick a side?
No, there are companies that pick the right technology for the application they're building. And in some cases, LoRa is a right technology for some of the battery-operated applications that are being deployed. So prime example is Cisco, which has both solutions. They have a Wi-SUN solution. They also have a LoRa solution. So yeah, it's technology agnostic, more about what is the right fit for the application you're deploying. So yeah, haven't seen too much of side picking just yet.
That's good. Yeah, it's always nice to bring that nuance back into it. It doesn't always have to be Sharks versus Jets.
That's true. Hockey fan, wow.
Okay, so the next sort of topic that we were going to break into is much more specific to Wi-SUN, sort of breaking apart what makes it different. Can you help us approach this next visual that we have on the upcoming slide in the context of, someone who may not be familiar with Wi-SUN, but maybe they are familiar with something like Wi-Fi or Bluetooth or something like that, or LoRa?
Yeah, let's do that, Kate. So diving a little bit deeper into the networking protocol stack architecture itself. So from the bottom here, we talked about the PHY and the MAC being IEEE 15.4GE based, and very, very similar to what some of the other protocols are also based on today. Zigbee is also based on the 15.4 protocol, as well as Bluetooth, and I believe LoRa as well. The big difference in Wi-SUN is there are a variety of PHY options available, not just the FSK, but also there are high data rate options with OFDM, and this is across all the global sub-gigahertz frequency bands, which is very different from some of the other existing protocols that are out there. The other good thing is the MAC, which is again based on the 15.4e standard, supports frequency hopping, and this essentially avoids collisions in crowded or busy bands, which is quite a big benefit given that this is a technology for dense urban smart city type scenarios. And then the next thing is, of course, on the security side, it supports, or Wi-SUN FAN defines a full public key infrastructure framework. It's defined and mandatory, required as part of the specification. So it is a certificate-based security framework. And again, with security becoming more and more important, this is sort of the highest grade of security that any of the IoT protocols have today as part of their spec. So it is the highest grade and the strongest, I should say, given, or when you compare it to some of the other IoT protocols that are out there. On the network and transport layer, very similar to Wi-Fi or IP-based standards. It supports both TCP, UDP, and also includes the 6LoWPAN packet compression specifically needed for IoT devices or running IP on IoT devices. So again, very similar to what Wi-Fi offers there today. Weissen Fan does not define an application layer, and this is mainly to allow customers to choose their own depending upon the smart city application. There were quite a few disparate applications that we looked at early on in the slides, and it's up to the customer to choose what's the best application layer they would want to go with. DLMS COSAM is very popular on the utility side. There is lightweight M2M or Usify that are gaining traction on the street lighting and some of the sensor node application side. But then again, it's completely up to the customer to either build their own or pick up something existing on the application side. So yeah, this is essentially a quick overview of what the protocol stack architecture looks like, and and a couple comparisons to some of the existing other IoT network protocols that are out there.
That's perfect. And as you mentioned, sort of that was it application agnostic? Was that the term that you used there?
Yep. Yep.
That's another way of helping future-proof as well, right? That idea of, why would you make a system like that rigid if you didn't have to, just in case, there are other advancements that occur, is the idea to let the companies sort of determine that portion, that piece of the puzzle, and hopefully the whole system has more longevity that way.
Absolutely, Kate. And that's exactly what the Weissen Alliance thought as well, that rather than defining one application layer and making it very specific to one vertical, let's just leave the choice to the customer and help them go whatever route they want to. And like I mentioned, there are a couple of popular application layers that are out there, but again, it's completely up to the end application OEM to build one and use one.
Perfect. And, basically, especially for the All About Circuits audience, electrical engineers, obviously, you yourself are an electrical engineer. My friendly stalking, you got your master's at Carnegie Mellon. I know that there's a really cool Metro 21 Smart Cities Institute there. So you came from a long line of professionals who can help maybe electrical engineers understand how to sort of synthesize the concept of smart cities and these very large scale systems. So can you help us kind of bring it down to the hardware level now? What is Silicon Labs in particular doing? What does that even look like at the hardware level?
Yeah, so Silicon Labs' Weissen solution is what you see here. From a hardware standpoint, we offer field-proven devices, which is our XG12 family. It is in production already, and you can get a lot of information on our website. I mean, you can look at the data sheet and get a lot of details from our website. So that is on the hardware side. Silicon Labs will also be offering a Weissen stack along with their GSDK. So the Weissen stack, we looked at the stack architecture in the previous slide. We will provide all the elements that are part of the stack and also a couple example applications to, again, help customers build their own application layer on top of the network layer. We do include a CoAP library also, which is of sorts an application protocol to help jumpstart some of our customers to build or to modify it to suit their own needs. Silicon Labs' solution will also include a border router demo because, as we looked at early on, Weissen does need a border router to form a complete mesh network. So we are providing a border router demo to help customers build their very own first Weissen network with Silicon Labs devices. Mm-hmm. Lastly, our solution will be fully certified. We will have the certified PHY as well as the certified stack. Today, the current version of the specification is FAN 1.0. FAN 1.1 is expected to come out later this year, and we will be certifying our devices even for that. One thing I would like to note here is Weissen does not restrict any customers on certification, in the sense a customer is free to use the Weissen solution without certifying their end product if they don't wish to interoperate with other Weissen devices that are deployed there. Mm-hmm. So there's no restriction or no requirement from the Alliance side if a customer chooses to deploy, say, a private network or a walled garden with the Weissen hardware and stack solution. So yeah, that's one thing I wanted to note.
Mm-hmm. For sure. And actually, that's brings up a sort of interesting side question there. When would someone, do you think, want to build that walled garden rather? When is that something that would be attractive for a designer?
Yeah, that's a great question. So there are times when, say, utilities want to build private networks for, say, a very small town. Utility networks need to be highly secure, and a lot of utility OEMs don't want external OEMs or external applications or other applications using their network infrastructure for hanging battery operated sensor nodes and things like that. So there are times when customers want to keep their networks very private and just use it for their own neighborhood or their own city, and not allow other vendors to use their infrastructure. So there have been a couple of cases like that, and this is mainly because they might not be using a full standard Wi-Fi network. They might be adding some proprietary features or differentiating features that is in their own network, and they don't want to expose it outside. So there are cases like that when customers would want to keep it as a private walled garden rather than being a full open interoperable network. And we've seen a couple cases like that.
And as you kind of mentioned already, sort of a running theme throughout here, if we can identify one, so the idea of that freedom at the application level,
Right.
specifically trying to design something that is open enough, it's secure and stable and capable enough, but then you basically have this framework and you can do whatever you want with it, right?
Absolutely. Exactly. Yeah, all the building blocks are given, and the customers are free to go by what the building blocks tell them to do, or free to build their own application over it. Our customers are free to use their resources and build the application layer, which is where they add value and which is where they can monetize with services and other things like that. So from a Silicon Labs solution standpoint, we will be offering all the foundational pieces to help customers focus their efforts on the application layer, because that is where their core competency lies, for sure.
Letting them focus on what they're actually good at, right?
Exactly.
Okay, so you kind of touched on it briefly there, but if someone were to want to get started in this space, as you already mentioned, you've kind of got this XG12 line for your dev kit. So can you help us put ourselves in the shoes of someone who might reach for this particular kit?
Absolutely. So Silicon Labs offers a Wi-Fi starter kit, which is based on our XG12 portfolio of devices. You can find it on the Silicon Labs website, and once you get it, you can build your very own Wi-Fi network with a border router demo and 2 end nodes that come with the starter kit. We have a number of different radio boards that are supported for global sub-gigahertz frequency bands, and some of them are listed over here. So depending upon which frequency band you'd like to evaluate or build a Wi-Fi network in, please order the corresponding radio boards to go with the starter kit. The starter kit also has 3 radio boards along with it, but if it is a different frequency band that you wish to deploy, then please choose the right radio board for your regional frequency.
It's an important note. You don't want to find that out once it gets delivered.
Right.
All right, and it sounds as though you guys have built something of your own kind of ecosystem as well on the Silicon Labs side. Is that a good way to think of it in terms of like how you guys are functioning, how you guys are choosing to move forward as Silicon Labs?
No, so Silicon Labs, again, we are an IoT company, and Wi-Fi is just one of the technologies that we support. There's a large portfolio of a lot of different technologies and protocols that Silicon Labs supports, not only as a stack, but also on our hardware. So we've been in the mesh space for a very long time now in the Zigbee mesh side. And now we're transitioning some of that expertise into the smart city side with Wi-Fi mesh. But that said, these are all the technologies that are shown on slide 12 is what we support today. And we've had a long legacy of supporting IoT technologies and IoT devices for a number of different applications.
Well, from your perspective, is there anything that you've kind of noticed about, obviously there are, I think a lot of people are going to be familiar with the Zigbee, Thread, Bluetooth, Wi-Fi, obviously, Z-Wave. Have you noticed anything in particular about the way that these IoT protocols are being developed? Are we developing in a particular direction, do you think? Or is it just sort of these pop up as a new application sort of dictates that we need it?
Yeah. I mean, we're on a high level. Circle Labs does focus on IoT for the home and IoT for industries or industrial space. And we've kind of grown in those spaces with all these different protocols. On the home side, yes, Zigbee, Z-Wave, Thread, Bluetooth, very popular. On the industrial side, especially things like commercial lighting, Bluetooth mesh is extremely popular. We have business on our electronic shelf labels where it's proprietary. On the smart city side, where it's proprietary, as well as Wyson. Again, other industrial and building automation type applications are looking at Thread as well as Zigbee. So lots of different segments and verticals among the industrial and home side that kind of have driven us to develop specific protocols that are needed to service the markets here. So, yeah.
Yeah, it's a big space, right? Lots of different
Exactly.
applications.
And we are a multi-technology company, not going to favor one over the other, but yeah, the right one for the right application.
Yeah, same thing. No need for sharks and jets. So there's room for everybody.
Exactly.
Awesome. Okay. So, I think there was at least a couple of closing thoughts here regarding, Wysun versus LoRa versus narrowband IoT, right?
Yeah, absolutely. So just very quickly comparing some of these LPWAN technologies or wireless technologies in the smart city space. Like we mentioned, Wyson is a comprehensive technology that offers a solution for both low data rate, high data rate, as well as long range applications, which may not be met either by LoRa or NB-IoT. And there are disadvantages and advantages to all of these technologies for sure. But we believe that Wyson is that technology that does comprehensively meet all the requirements in the large network space on the infrastructure side. So just a couple points here that kind of show how they stack up against each other. At the end of the day, yes, it is very application dependent, but we do believe that Wyson can indeed meet a lot of those requirements for those disparate applications that we talked about early on.
Yeah, it's really handy to see this sort of side by side, just because it's such a broad space, because there are so many applications sort of wrapped up into this, IoT space. It's kind of a lot to keep in your head all at one time, isn't it?
Absolutely, yes.
Awesome. All right. Well, Soumya, thank you so much for your time today. This has been really illuminating. There's so much going on in the space of smart cities and helping us learn how to translate that down to the hardware level. And there's a lot going on. But as you said, Wysun's the new kid on the block, and it'll be really interesting to see how and where it's getting implemented across the globe. So thank you so much for your time and insights.
Definitely, Kate. Thanks for having me. This was fun.
It was fun. Thank you so much.